Alright, first problem from last biweekly contest. Transform array by parity. We're given array nums and we need to transform it in this format. Replace even numbers with 0, odd numbers with 1, and by the end it should be in non-decreasing order. So since the result will only contain zeros and ones, it will be in this format. What we can do is we can keep count of all the odd numbers because that will be equivalent to 1. That will give us a count of all the odd numbers and we can create an answer of this size. Default values will be 0 and from this right side, from the end, we'll start filling it with 1 until we exhaust the count. Alright, so we can have n, we can have a count that will be of 1 and let's get the count that will be if count or if nums of I mod 2 not equal to 0, then increment the count, create a vector of size n, start iterating from n minus 1 until we exhaust the count. So count should be greater than 0 if we are within the loop, and let's reduce the count here as well and start filling answer of I to 1. Let's return the answer here. Let's submit it. Time complexity will be O of n. Space will be O of n if we count the result array as well, right? Let's move to the second problem. Find number of copy arrays, right? So we get an array original of length n and a 2D array bounds which contains elements in the format ui vi, right? We need to find the number of possible arrays that we are calling copy that will also be of length n such that this two conditions are satisfied. First condition states that the difference between the first and the adjacent elements will be equivalent to the adjacent elements difference in the original array, and the copy of I value should be within the bounds, so it should satisfy this condition as well, right? So straightforward problem. We're given a 1 2 3 4 in the first example and we are told that this is the bounds. The possible arrays will be 1 2 3 4 and 2 3 4 5, right? So what we can do is we can just iterate through the original array and keep updating the bounds based on the validity of the previous arrays or previous elements that we have seen, right? So basically if we have something like let's say 3 4 5 6 7 8 8 and the bound is something like 3 or 1 3 2 7 3 5, right? So we can't really change the order of this because this every element in bounds refers to the current corresponding element in the original array, right? So if we have something like this, right, so what we will do further, there are corresponding bounds for these three elements as well. Here what we can do is we can traverse and we are going to see, we are going to traverse from this point and we are going to see the difference, that is 1. We are going to update the bound of this to keep the validity of the further future bonds, right? So what we can do is 1 comma 3 will be changed to 1 plus difference, 3 plus difference. What is the difference? Difference is 4 minus 3, that is 1. So this will be 2, this will be 4. So 2 comma 4 is the new bound of this 1 3. So we are going to find the commonality between 2 4 and 2 7, and that is nothing but maximum of the lower bound of the two elements and minimum of the upper bound of the two elements. So maximum of 2 comma 2 and minimum of 7 comma 4, that will give us 2 comma 4. That will be the new bound for 2 7, right? So let me write it. 2 4, right? This will be the new bound. Now when we come here, so we are going to overwrite this, so we are going to lose this and overwrite it. We don't need the previous one because the previous 2 7 was breaking the validity, right? At least some part of it was breaking the validity. 2 4 is not breaking, and we are going to continue forward. And initially we can have an answer. We can have something like end max or anything, any greater value. Technically we don't need int max as well. We can have some value that we can calculate and see what's the maximum it can be, but I'm being lazy and using int max as the initial value. Now it will always going to decrease as we move forward. It is going to be as low as 0 or something above, so it can't go negative, so we can take care of that as well. So we can have scenarios like something like 57 60 82 84, and we can have some bounds like 67 to 106, something like this, and something else. So here if we try to do it, we see that the difference is 3. So this should become technically, if this was the case, right? So in that case the difference is negative 3. So this will become 64 to 103, right? So in that case we can see we can move forward. But if we get a scenario like the new bound of this 4353 is something like x to y, where y is less than x, in that case we can safely return 0, right? Because we have nothing in common and it can't go worse than 0, so we can return 0 there itself, right? So straightforward problem, just a little bit of edge cases here and there. So what we can do is we can have an answer. Initially int max, we'll traverse we are going to get the difference. So we are going to start from the first index so that we can betray the edge cases. So I minus originals of I minus 1, right? So here we get the difference. We are going to get the previous lower bound, that will be nothing but bounds of I minus 1 0. Similarly, previous upper bound, this will be 1, this will be 0, this will be 1, this will be current lower bound, current upper bound. So let me update this. Alright, so at this point we can get the things that are in common, right? So things that are in common is nothing but minimum of current upper bound, comma, previous upper bound minus max of current lower bound, comma, previous lower bound plus 1, because we are going to count the number of elements within this range, so we have to do a plus 1. And if common is less than equal to 0 or less than equal to 0, yeah, return 0 here itself. Otherwise just minimize the answer. Let's not forget to update the bound for the next bounds, right? So the bounds will become this, actually this for the lower bound, and for the upper bound it will be minimum of current upper bound and lower bound. So this should be it. So we can return the answer here. Let's see if this works. Oh my bad, I'm extremely sorry. I forgot to increment the def to convert it to the new lower bound and upper bound, and again, and then find the commonality. So what I'm going to do is get the previous lower bound and add the difference to it. Get the previous upper bound and add the difference to it. Upper bound plus diff. So now the commonality will be with the current and the new lower bound upper bound. Oh my god, this should be upper bound, this should be lower bound, and this should be it. Yeah, now this should work. Okay, my bad. This should be lower bound. Yeah, this should work. Let's see now. Yeah, the time complexity will be O of n, and space complexity will be constant. Let's move to the third question. Find minimum cost to remove array elements. We are given an integer array nums. Task is to remove all the elements from the array by performing one of the following until nums is empty. Choose any two elements from the first three elements of nums and remove them. So the cost of this operation is the maximum of the two elements removed. If fewer than three elements remain, nums remove all the remaining elements in a single operation, and again the operation should be the maximum of the remaining elements. So we need to return the minimum cost to remove all the elements. So this should give us a little bit of intuition towards DP, and that's how we are going to solve this problem. So what should be the states is the question when we talk about DP, right? And I'm specifically talking about top-down approach. Bottom-up approach requires a little bit of different thought process, but this one requires the states. What we need to identify the states. So, well, nums will already be there, but we need to identify the other states that we can have some idea using the constraints, we can afford a O of n square solution, right? Where n, I mean nums dot length. So what we need to do, or what we will be doing, is we have some elements a, b, c, d, e, f. This is suppose nums. So what we are doing is essentially we are removing the first three elements. Not removing the first three elements, but among the first three elements we are removing any two. That can be this two, that can be this two, that can be this and this, right? So we can have, so first of all we are not going to literally remove the elements from the numbers array, because that will be very inefficient. But we can afford to ignore the others. So there can be a pointer that can act as a wall to ignore the previous elements. But we need one element to not ignore, right? Why I say that? Because we can have scenarios. Suppose this is the numbers array and we have removed every element before f. Suppose we are here and we have removed every element here except this one. Let me point it using this. Okay. Only this is remaining, all the other elements are removed. This can be a scenario. Let me show how this can be a scenario. Suppose we are here, we see that these are the three elements. We remove A and C, we keep B. Now this are the three elements B, D, E. We remove D, E, B is still there. Now B, F, G. We remove F, G, B is still there. So there can be a scenario like this, right? So we definitely need a state that will be index and a last index. Let me call it L, right? So L and I, initially when we start, we can have L as the first element and I as the, sorry, L as the first element and I as the second element, right? That's how we are going to start the DP. And there will be three scenarios, three choices, and those three choices will be basically incrementing. In all of the choices we need to increment index by 2, 1, 2. So we are going to lose two elements, right? That's why we are incrementing the index by 2. So index should be incremented by 2. Let me copy this 3 times. The second state will be L. How should it change? Well, if it was L, it can still remain L. That means I removed I and I plus 1, right? These two are removed. So that's one choice. Second choice is L is removed now and I am, the new L is I, or the new L is I plus 1. That's it. That's all we have. And this will be the state. What will be the cost increment? Well, that will be among I plus 1 and I, right? So max of nums of I and nums of I plus 1. Here for the second case, what should be the increment of cost? Well, it should be L and I plus 1, right? For this one, it should be, since we are leaving I plus 1, then the other two choices are L and I. So L and I, right? These are the three choices. We are going to memorize this. We have two states, I and L, or I'll call it index and last index, right? This will be the memoizations of these two states, O of n square, and space also will be O of n square, right? So let's do it. Solve it. Nums index initially will be 1, this will be 0, and this will return integer. I will have the same naming as we discussed, index and last index, or let me call it left index, that is more appropriate because we are leaving this index, that's why. So if nums of, or what are the base cases, let's discuss that. So we have this, and this is always valid and will work fine when we have 3 elements, but when we have 2 elements this will break. So for that we need base case, and that will be basically a scenario which will cover this scenario. In that case we return 0, we don't have anything, we have exhausted everything. And actually we return my bad, see, since we have left index and we are looking forward from nums of index, right? But we have left index previous to it, so we should return nums of left index, right, instead of 0. And there is no concept of negative value, so we don't have to worry about that. So this will be the return if index is greater than equal to nums. So let me comment it, index uh, when array exhausted, return the remaining element, right? So in this case the other case will be remaining one element. Then when we have only one element, in that case we, that case this is the scenario, and we return, since there is no only two elements, and that two element will be nums of index or nums of left index, right? So when I say remaining one element, that is from index, but before index we have already one element, that is nums of index, nums of left index. That's why we have two elements here. Right? So I'm sorry. Let's have max here. And finally, now we are good, because when I say remaining two elements, that means we have three elements, and our DP function or the three choices can take care of these three elements. It's not going to break. So we can have an answer initially int max, and we can just iterate, oh sorry, not iterate, just we can define the three choices. That will be basically minimizing answer first of all. Return the answer here. Let's now discuss about these three choices. That will be max of nums of I, comma nums of I plus 1, and there should be index instead of I, so let's be careful there. plus solve function nums comma index plus 2 comma last index stays last index in this choice. Now comes the part where we have nums of index. Let me take last index this time and nums of index, right? Plus solve nums comma index plus 2 comma this time index plus 1 becomes the last index. Finally, let me copy this. The last choice between last index and index plus 1, and this time index is the last index or the left index. I'm sorry if left index and last index was confusing. I was interchangeably using that. So lastly, we try to submit it and then we'll memoize it. So for that, let me create a cache. Okay, first of all, there is some mistake here. Alright, so this should be left index, left index, left index, left index. My bad. And let's see now. Alright, this works. Let's get the cache. 2D cache. nums.size plus 1 for good luck and vector of int nums.size plus 1 initially negative values. We are going to check here after all the base cases if cache index and left index is not equal to -1, then let's return this and let's update it with every answer. Let's see if this works. Alright, this works. Time complexity and space will be O of n square. Thanks.